All right, welcome everybody. Thank you for coming. This is our first lecture in our spring speaker series. This spring we're doing a series on innovative homes, so that we will have case studies on houses or residential buildings that achieve net zero standards or have undergone a deep energy retrofit or some combination of the two. So we're really glad to have you kick it off with Eric and Arthur. And there will be 4 more after this, so you will come back every Wednesday right here, same time, same place. They will also be recorded and put on our YouTube channel after, so if you miss them and you want to just catch up on the YouTube channel, that's a great option as well. A couple other notes. Restrooms are back towards where you came in the door in the lobby. There's some water and cookies up here for you to enjoy. Eric and Arthur will probably talk for about an hour, maybe a little longer, and then afterwards we can stay in the hall and hang out and chat, and yeah, come back there. Another thing that I'll just put out there, we have a Standby for Locals program, so if you're a resident of Washington County, you can put your name on the list, and we sometimes offer spaces for classes at a 50% discount when we have spaces left to fill. So hop on that list if you're local. We are a nonprofit, we welcome donations, and thanks for being here. And I will hand it over to you.
Thank you. We're going to, Eric's going to present first, and I'm going to present after. Eric's going to set the table for what I'm going to talk about. But we're going to first try to introduce each other, just for the fun of it, without any prep. So Eric Morrow, architect. We've known each other for 12 years or so, and we've only worked together for the first time kind of recently on the project, since he's switched career paths from kind of being straight up in the architecture field and going to more envelope commissioning. That's primarily this. But Eric's been an architect for a long time. I can't remember how many years, but a long time. And he's also served as the president of the AIA Vermont chapter. And he also started the Burlington 23rd district, which he then was commutes to go for a while. He also likes to ride bicycles. And if you ask him what his favorite thing about riding bicycles is, it is to turn. So the turns are the best part. So let's kick it off. Cool. Thanks, Robert.
And I also want to introduce Chukhman. While I'm here, I'm going to clip this to myself as well. I hope I can compete with that introduction. Arthur's also an architect. Who's just in it for the money. No, just kidding. No. Arthur's been an architect for quite a number of years and works in a lot of low-income housing projects. So making a big benefit for his local community. He's a member of the AIA as well. Other project types include custom homes, small bespoke, highly crafted projects, tiny homes, ADUs. Arthur also designed his own passive house, which we're going to get a chance to see later. And I will share that Arthur's newfound love of hand tools, hand craftsmanship, which includes a block plane that's like as long as this desk, like a huge block plane. So if after the presentation you want to talk about how sharp you can get a block plane, Arthur might be the guy to talk to. So,
Thank you.
Yeah. Cool. Thanks for having us. About the presentation, just like jump in with questions. I'm going to keep it casual here. So, I want to touch on this idea of form collectivism. Anybody have a guess as to what this first image is? Or what state or where it is?
Nevada.
Pennsylvania.
Yes.
Is it Levittown?
Yes, it
Oh.
is. Levittown, PA. This was a movement, this particular development project was in the 50s. Think post-war housing, post-World War II housing crunch. GIs returning, population increasing, and here we have an urbanism, a built pattern that wasn't perfect, but it was a pattern that people came to use and enjoy. This is just one example of pattern development. That didn't go the direction I thought it would go. Not on the computer. I use the arrows. I'm in the pants. Yeah. All right. Second example of patterns in architecture. Any guess what this is?
New Orleans?
Yeah.
What is that?
New Orleans?
It does have a New Orleans vibe, but not.
Montreal.
Yes. Yes. This is in Montreal. This is an area called Plateau, and for its wonderful culture, it's really a beloved place for Montrealers. A lot of families grew up here. It's a very multi-generational part of Montreal. Probably 600,000 people. No, I'm sorry, 100,000 people live in the Plateau. It's 3 stories tall. You can just see from the edge of the photo. Modest building height. Quite a bit of repetition. There's 3 stories, 3 different condo units or apartments, and it's a strong pattern throughout the neighborhood. 100,000 people. We see a lot of this. The reason for the stairwell is because the zoning actually allowed stairwells to be within the building setback. So external stairwells got popular for some reason. But here's a very nice example of patterns in architecture where I think they were quite successful. So when we depart, what's the antithesis of collectivism is individualism. So when we think about patterns of development, patterns of architecture that are really about one person, any guess where this is taken?
Newport?
Dorset.
Oh, close to Dorset. Paramount. Yes. This is Spear Street, just outside of Burlington. So you can think of a lot of homes, or maybe even commercial buildings that are screaming individualism. And it's something that we consider is what are advantages of patterns in architecture versus high levels of individuality, and what sort of outcomes do we get with either. So I only have a couple more slides. My bit here is quite short. But what I want to set up is this idea that patterns in architecture that can be used to address our current crises. We'll just say a climate crisis. And we could also say sustainability. We define sustainability as providing for our own needs without encumbering the needs of future generations. We don't want future generations to have a rough time because of decisions we're making today. So what are patterns of design, patterns of architecture that can lead us to bounty and sustainability for those future generations? I'm going to go on a little bit of a guess in my own work in that moving buildings towards the light, towards the sun, is a way for us to create a pattern that's going to be sustainable for us. So I'm showing a sawtooth building profile because one side is collecting sunlight for solar panels. This is a little sketch that I did for a friend, client also. And so there's a little bit of their design in it, there's a little bit of mine, but this is an example on a residential scale of unloading a lot of solar onto a project. If you look at the back of the building on the back side, We're just making a strong commitment towards where is the sun coming from and how can we harvest that energy to close the gap between something that's passive house and something that's net zero. The passive house will get you about 80% of the way to net zero, but to close that last 20%, we need renewables. What makes it a little bit more challenging is now that we're driving EVs, we need more charging capability. You got 1 or 2 EVs at the house, you're going to need additional solar to support that. If we're zero out our grid. Forms that kind of take me in the direction of this renewable direction, kind of simple, kind of modern, and coordinated with the sun. Last slide. So this is an image that I think of. These are, of course, sailboats in a mooring field in a harbor, and boats are mandated, and here they are interfacing with nature. They're ready to take the storm. They're in kind of a survival mode, which I think we find ourselves in now, also. And they face into the wind, and should the tide change, the boats all swivel, to coordinate with the direction of the tide. The tide changes, the boats swivel again. So this is just, for me, it's been a remarkable example of how humans can get into a pattern and be very coordinated with nature in order to survive. I could show a picture of how a sunflower tracks to the sun, but I don't think that really tells the story, enough of the story, of how we're different from nature, but we're also trying to be coordinated and work in harmony with it. So I like this example because it's really coordination with nature, as opposed to emulation. Emulating the pine cone, emulating the sunflower. Those are different ideas. So, with that, patterns of design.
Hi. So, I think what Eric kind of laid the groundwork for is thinking about how today's architecture can respond to our current crisis. And so where I want to take this from here is, first I just wanted to kind of share the house that I built for myself. I just want that, the name is the address, but it's just, I think it's a good case study that shows my process in thinking about design. And then we're going to get into kind of similar to tracking the sun, how these passive house strategies affect the form of an architecture. But I think the main course of this presentation that I want to talk about is like how we think about detailing specifically, and like on a really small level, how you can really decorate that form. Like if the bigger form is what your solar orientation is doing, or your massing, what about the little details? How do those express themselves with the way that we're designing these kind of new high performance buildings? So to me, I think it's a really interesting part. It's something that not a lot of people are talking about. Like we're talking about, often you see architecture that is very different inside because it's using all these new technologies or new strategies or new detailing, but it looks the same on the outside. It looks, we're trying to copy like a particular historic style. And I think what I'm interested in is exploring kind of the new form that you can, that these details are expressing. And then at the end, I kind of talk about some of the things that are maybe harder to express, but maybe other people can figure out ways to do that. And then we'll have questions of that. So this is my house in Burlington. I like to just credit the people that were involved in doing it. New Frameworks was the enclosure contractor. Chris West was the energy modeler, and Taylor Ritchie was the carpenter. This is kind of just giving you where it is. This is the neighborhood. A lot of mostly two-story, but some three-story buildings. This is the north end of Burlington. My partner and I bought this duplex, and we wanted to put on an addition, third unit. So this is the before, and this is the new addition on the back from the street. And then in the back, this is actually slightly after demolition, we took off a single-story 3-season room on the back. That's why you see the tarp, but then this in the back. And just to kind of explain what we did, there's 2 units in the front, unit 1 and 2, and we added this 3-story portion, but as you can see, a little bit of it went to unit 1 and a little bit went to unit 2. So the new unit is actually not the entire new construction. And then the basement is all common space. And so when I talk about this is a passive house building, only unit 3 is a certified passive house, but all the new construction is built the same way. Just to kind of quickly run through plans, you can see the bedroom, bathroom, and entry was added to both first floor and second floor for each of the apartments. And then unit 3 has an entrance as well. And then so second floor, there's some stairs coming up into that unit. And then, so I'm gonna go back one. So in the new unit, it's kind of a reverse living style. So you have bedroom and bathroom entrance on the first floor, and then as you go upstairs, you have another bedroom, bathroom, and then on the third floor, it's a big open kitchen, living, dining, and roof terrace. This is kind of the little cross section, mostly for reference, but you can see how just kind of stairs go up. But what I really wanted to talk about is what are these driving forces that normally inspire us in architecture. And this is kind of an image that I like to use. This is looking down, standing on the top plate of a wall before the wall went on, and it's a high density foam thermal break inside of the foundation wall that it's from an interior insulated wall to a non-insulated concrete wall. And it's very abstract. And what I like about it is like finding kind of art in like this is, in this case, it's kind of more of a graphic art, the firing inspiration from the details. This is a little detail.
That's unedited?
This
That's
is
not patchwork.
no, this is like looking straight down.
Yeah.
Yeah. These are kind of the high performance passive house, whatever you want to call it. These are some of the strategies that I can think of that are what people talk about when they build high performance. So you're going to have an envelope that's well insulated. You're not going to have any thermal bridging. You're going to make it really airtight. You're going to put in ventilation and heat recovery. You're going to optimize solar gating, and that both means the orientation and where the windows are placed. You're going to have a low window to frame and glass ratio, which I'll show you in a second. You're going to have a compact form in a northern light on it, and you're going to, because of that, you can get away with minimal heating and And so these are some of like the big picture strategies that I call for passive tiles, but we'll also get into some of the details, which I think are more interesting. So, thick envelope, we don't need to go through this whole slide, but I just wanted to show, like, everything's thick, right? The walls are thick, the roofs are thick, you need the space for the insulation. And I think that's really interesting, like, you went in the last 10 years, all our walls and roofs got thicker. What does that mean for the form of architecture? I think it's gonna have a very different look. And so how can we work with that rather than fight it, right? Like, I think we should celebrate these thick walls, and they can be really beautiful. A lot of masonry buildings always have thick walls just for structure, but now that can be at the residential scale, which I think is really interesting. Like some of straw-bale homes have always have thick walls, and I think that's a really beautiful aspect of them, to have these deep window wells. And I think that is something that we should kind of it's a selling point for me when I'm talking to clients, is you have these thick walls. And then because of that, you have these deep windows that are, if you locate them in the center of the wall, where that's thermally the most optimal place to put the window, right in the middle of the wall. So you have less kind of thermal bridging. And you get these, it actually does a couple of things too. Thermally it's better, but also the wall itself shades the window. And so your southern windows that require shading in the summer and don't want shading in the winter, that is like a built-in little awning that shades just enough. And we find that this kind of 6-inch deep shading is actually pretty effective. And you don't need to build like formal awnings on the outside. And then back to just kind of this idea of the window frame ratio. This is just showing how if you take the same amount of glass in 3 windows, your frame, square footage for the frame, in this case, is 11 1/4, and the square footage of the frame for the big window is 6 1/4. So if the frame is the reason that we do the strategy is the frame is the weakest part of the window, it's the lowest R value. And the glass is actually quite high on that, especially when we do triple pane glass. Then minimizing the amount of frame is energy efficient. And so what does that mean for architecture, where all of a sudden big windows are more environmentally friendly than small windows? That's going to have just a very different look. So I think just kind of recognizing that all these little efficiency measures that we're doing are slowly changing the looks of our building, I think is really important to recognize. From a cost point of view, it's also cheaper just to do less windows. Every time you tape the frame, there's less tape you're going to have to use, and overall just a cheaper way to build. Low surface area to volume ratio and using simple shapes. Just not a lot of jogs and very simple forms, and less corners is going to be cheaper and less thermal bridging. And so how do we make beautiful things that are really simple? I think that simplicity is not just an aesthetic choice, but now it is a functional choice and a cost choice. I think that's really important. I just wanted to show the continuous installation on this project. I tried to do this project without using any foam, and so the exterior installation is all fiberboard. It's about 6 inches thick. And so that's a major new component in this thing that you're designing. It's this where, maybe if it's 1 inch, it's not really a significant part of this thing that you're designing. But 6 inches, that's like a big jacket that you're putting around your house. And I think that should be expressed somehow. Like, you should be able to see that. And I'll show you a little later in how I thought about that. I just wanted to show how we did look at the solar shading on this project, and wanted to just kind of prove out that the windows are in fact shading themselves effectively with the overhang, and that the orientation of the house is not overheating, but is still having some solar heat gain, basically dial that in a little bit. And, you can use this with your energy model to kind of optimize how big your windows are or where they should go. And then ventilation, just wanted to show this house has a heat energy recuperator and ventilation. That's not the main part of this conversation, but I just want to at least show that this is part of the process. And maybe there's a way to kind of express that in a more significant way, but I'm not saying that it's out there in this project. And the heating is this, you can see that it's a heat pump over the door. This whole house is heated with two of the smallest heat pumps that you can get. And the reason one would have actually done it if you just do the math, but because it's 3 stories, you just need it for distribution. And then I wanted to kind of talk about this detail of the attic, and the way that I thought of it was I wanted to do it foam free, and so that meant essentially cellulose, or it would have been very expensive to do fiberboard on the top of the roof. That's the other option. But cellulose means a vented system, and so you have a cold roof. And so I knew that I essentially needed an attic, but I couldn't resist cathedral ceilings. So the kind of sweet spot is if you have like an 18-foot span, you could do a scissor truss that can span that whole thing. And if you start with a truss heel at the bottom of 2 feet, then by the time you get to the top, because the inside of the space of the truss is 10-12, and the outside is 12-12, the center becomes about 3 feet, just enough you can crawl through, and you can blow in cellulose from above like a normal attic, rather than try to dense pack it from below, which is way harder. So I thought it was a pretty clever system, and kind of saved a little bit of effort, I guess, and money. But you can see on the top left the little hole that's not being crossed through, which was not baby. And the picture below that shows kind of the baffle that makes sure that once you fill it up with cellulose, there's airspace that dries out of that attic. So here's the detail that I want to talk about, and that's the roof edge, where the roof meets the wall. And I spent a lot of time thinking about this, and I'm like, okay, what's a traditional roof edge, and what are the functions of it? And one of it is to let in ventilation. It has a downward facing soffit, right, that you normally use to vent the attic. That's the blue arrow showing that. And it shades the windows. And traditionally, windows, the roofs were a little lower. We didn't have a heel necessarily on the truss. And so they could really shade the windows, so that you can have a good overhang and it'll shade the windows. And it also, it's a place where you potentially harvest water. And for me, gutters, having a gutter was really important. We wanted, it's a little bit of a resilience thing where I wanted to collect water for use of mostly gardening, but it's a little bit of a prepper in me that's like, I want to have water on site that I can just collect on site. And so collecting water and expressing it was a big part for me. So the next step from that kind of traditional way that we frame a house is something like this, where you'd see, okay, now we have a wall with continuous installation, and we have a truss that has a heel on it, which allows for 2 feet of insulation without compromising that right at where the roof meets the wall, and it still allows for ventilation. So this is pretty good. So I guess I put this in here just because I actually, this is a tool that you put on windowsills that then you then plug in the data into an energy model, and it kind of shows how much shading there is. And on my site, it showed that there was adequate shading where I didn't need an overhang for shading specifically. And so that started to change my thinking about, that was one of the major things that a roof overhang does, right? And so this is the detail that I ended up with. And, I forgot to mention, the other one thing that overhangs do is protect your siding. That's like, if you have a wood siding building, which we've been doing forever, you gotta have huge overhangs to protect the siding from weather. And that's rain and sun. And we decided, we have a 3-story building. And so, well, all of a sudden, I don't want to paint wood 3 stories up, especially in the eaves. It's like 4 stories up in the air. So we decided to go with metal siding. And metal siding is the same material as the roof. So all of a sudden, I'm like, okay, don't care about protecting my siding as much. And then shading, I've kind of showed that you can actually, you kind of can see the diagram as like, there's adequate shade without the roof overhang. Plus, it's a 3-story building, so the lower stories wouldn't be shaded anyway. And so I decided to not really have a overhang. And then I was thinking about how I wanted to express that thickness of the insulation. And so the idea that I cut out the top corner of that insulation where it meets the roof, because that's actually where the insulation is doing the least work, right? Like if I just run that insulation all the way to the top of the heel, it's not, that really top corner is not doing much. And so this detail is now showing that I don't need insulation here. It's kind of expressing that idea. And instead, I put the gutter in that location, which is kind of sized the same as the thickness of the insulation itself, the continuous insulation itself. And I wanted to express that gutter, and the importance of that gutter architecturally, kind of put it up on a pedestal. And so I had the ventilation run under the gutter and behind it into the baffles, as you can see these little blue arrows. And that created this nice little shadow line under that gutter and kind of expressed it a little bit more. So this is it at the end. The top one is obviously a construction detail, but once the gutters do come out to the ends, they kind of get expressed by being elongated and holding the downspout off the building quite a bit, because I kind of wanted to celebrate them a little bit. And they, on one side of the building, the water gets collected and goes into this giant water barrel that is located at the bottom, or at the stairs, it's landing. So these stairs are much longer. From the top floor, from the 3rd floor, you can look all the way down and out of this window, and you just see the water falling into this barrel. And so just kind of a reminder that I like that talks about the importance of water and just kind of, rather than kind of making this hidden system. So that's kind of the main way that I want to use that details and express it, like just to show how I think about the details and how they relate to the form. But I wanted to also show how there's like all these things that we're doing that we maybe haven't done before historically that are much harder to express, and maybe somebody in the future can express it, but it's things that I haven't really figured out yet. Like, one is I used Laval insulation under the slab, which is a recycled product using glass, and it's both a gravel and an insulation, and that's buried right under the building, so nobody ever sees it. And I'm not sure how to express it, but it was a big kind of change in the way that we design foundations. Also, some of these like little thermal bridging insulations where we modify the footing and put insulation in between slabs. All these to get hidden. So that's that detail at the bottom left where prevents two slabs from touching. So this is kind of looking down at that same foundation, and you can see sort of, if you look at the middle of that foundation wall, there's a slab that's exterior and a slab that's interior, and there's kind of this foam, little foam thermal break that went into the foam. And then there's all these like air sealing details, right, that kind of we put a lot of energy into, but you never see. The top corner is just like pipes that somebody meticulously air sealed, or the bottom one is screws that missed that somebody went back and caulked. Those are all really important, but we never see them. The top right picture is my ceiling has an air barrier in it, and lights that penetrate it need to be contained somehow. And all these lights had these transformers with them, right? So you can't, it's not just a box. And so I went up into that tiny attic and built these little boxes and taped them all, and spent a lot of time up in the attic. Those just get hidden up there. But maybe, I think like that could be a detail that somebody expresses. Like maybe it comes out or something. But I think they're all like opportunities for inspiration. And then this is just showing that to certify passive house, you have to have very small amount of piping for your hot water. And so like the location of your boiler needs to be like pretty close to everything, or you can't have these long runs. I even had a plumber change one of my pipes from from 1/2 inch to 3/4 at the very last run, and I had to make him change it back just because it like threw off the calculation. So that was a lot of energy that was put into something that nobody will ever see. But maybe there's a way to locate the hot water tank in a place that is somehow expressed in form. So that's it for my slides. Yeah, I guess I just wanted to open up that idea of expressing these things to you guys and have a conversation about this concept. Or yeah.
You talked about the requirements for being a certified passive house. What are the benefits to certifying a house as a passive house rather than just incorporating those details?
For me personally, or in general?
Both, either.
Yeah.
Yeah.
I mean, for me, it was a proof of concept.
Cool.
I just wanted to make sure that I was ticking all the boxes, and because I'm a professional, that's useful for me.
Yeah.
For somebody that somebody else, maybe I think that the benefit is you have more oversight, and there's what one some might say minutia that we get missed, but there is a level of detail and oversight. Like I probably wouldn't have done the water calculations, right?
Yeah.
It's a good idea to locate the water tank in a good central spot anyway, but I might have not done the calc. So I think for a single family house, it's less significant than a bigger project where there's just a lot of things to think about. And here, you actually do some of these kind of like envelope commissioning stuff. Maybe you talk about like some of the benefits of the actual certification versus.
Yeah, I would say, I kind of echo what you said. There is something to the benefits of certification for the practitioner, for the builder as well. You know, to go through the hurdles at least once, maybe a couple times.
Yeah.
And then there's certainly third-party verification is great for an owner. You don't expect the owner to be expert at all 7 key bullet points of making a passive house. And you know what? The owner should be able to check out. They're paying a team to deliver a high-quality product. Third-party verification, to me, is a great way for the owner to have a little extra verification that the goals that were talked about early in the project were actually followed through.
Thank you.
Good question.
I'm trying to ask, what was your favorite detail, but in like a more, technical way? Like what to you was the most exciting or innovative solution to a problem that you saw? I can tell you like the gutter.
Yeah.
If you exclude the gutter, what would
Right.
the runner-up to that? Like something that's doing a lot of work in the house, it's also expressed that, like when you come home,
Right.
you're like, nailed it.
There's certainly a lot of like. I've showed how these performance details can be expressed. There's certainly non-performance details that can be expressed all the time. And so, when you can do it both. You don't only have to choose these kind of like technical details that get expressed. I'll share like more of a construction detail that I really enjoy, which is have these in the bathroom. I have these reclaimed slate tiles that are this long, this thick, or this wide, and like 3/4 of an inch thick, super heavy. And I personally pulled them out of the building that they're going to demo those slates. And I stacked them up ahead of time. I pulled them out of the 3-story building by myself, like put them in my car, and I couldn't handle that load. And like had them in my backyard, moved them around 4 times, like during construction on a tiny site. And then, in the end, you bring them upstairs, and then you realize you have to recut them outside, and you bring them back downstairs. So it's like this constant like stacking and moving of these super heavy slates. And then when we had some scraps left over, and I wanted to design a bench in the shower, I was like, I'll use these scraps. And I designed it by having the face of the bench express the thickness of that material, and I just stacked these little strips of them in and out, just to show, like, as if you had a stack of slate. And like every time I'm in the shower, I'm like reminded of like the process of like building with this material. And so like I think there's a lot of those details that I really enjoy on like a daily basis that express maybe not the function, but at least a process.
I followed the project during construction, and I remember walking by the site, when the hole was dug, it's raining cats and dogs. I'm pretty sure like the earth looks like it's caving in to the site. What's your motivation when you're at the maximum loan to the bank and the site is the maximum exposed? Like, what kept you from losing your mind at that time?
I think a lot of it was optimism and ignorance. I think I knew less back then than I do now. So there's some of that. Yeah, like, there's also excitement, right? Like you're getting this new thing, and at the end of the day, like there was no huge things during construction that like were really bad. And I had more energy back then. I like after work would spend like 4 hours, because I GC'd this project, did all the carpentry of like putting in temporary stairs and all that stuff during construction. Did a lot of finishing work, but yeah, you have more energy when you're younger.
I mean, for a slide, you can list yourself as the GC, because that's a big piece of it.
Yeah, that was a heavier lift than I thought, and made me appreciate general contractors way more than I did before.
Could I ask like a two-part? So you obviously spent a lot of time digging into the detailing, right? So I'd be curious to hear, is there anything that went well but you would change? You know, where you're like, oh, that was a good kind of first pass. Next time I would go 8 inches of whatever. I would use rock wool next time instead of, you know. And the other question I just had with some more nuts and bolts is, I saw a CDX sheathing in there. What did you use for a WRB, or did you just rely on the text?
The good text. Yeah. To make the budget work, I took out the WRB. But also, it's advertised as being the WRB.
Yeah.
So I think it saved like $5,000, not in the house again. Especially a tall house. Right? The scaffolding was, a big hurdle, and this isn't an answer to the first question, but like it's the liability of scaffolding and that you can't just put it up and everybody uses it is really crazy to me. It's like I had somebody that owned their own scaffolding, but like they didn't want to give it to somebody else who could fall off it and be their liability. So there's like a lot of like weird contentious things like that.
Couldn't you set up as a GC and just assume liability for people falling off?
But I didn't. I didn't know. Yeah. So like one person had scaffolding, another person had, and they did actually share it with a few people, but the envelope team wanted to have a lift. So it's like weird construction and stuff like that. The one happy mistake was that my excavator was not great, and they're very nice, but they dug the hole not deep enough, and so we had to scramble and like adjust things. And so, at the end of the day, it's fine. I actually made things better in some places and worse than others. But like I wanted like 9-foot ceilings in my basement, and I ended up with 7 3/8, which is like or 7 foot 11 3/8. And so it's just small enough where I can't lean up a piece of like plywood on the wall unless it's at an extreme angle. So it's kind of funny how even if I took an inch more from my basement, I would have been happy. But it actually made like the alignment up to the roof terrace a lot easier, and I did not have steps up to that. So actually it ended up being fine. But it's funny things that you have to fix during construction. But I keep thinking of what is a real thing that I would do differently.
Other than hire a different, an excavator who digs holes to the appropriate depth.
They can read drawings.
Yeah.
This is kind of a minor one, but like, I really value good windows, and these are really good windows. These are Shuko windows. They're UPVC. They're the best glass you can get, and the frames are pretty decent. But they do offer one that has like foam inside, which are even better. And every now and then, like, I'm like this is obsessive, but like you can feel that it's a little colder there. And I was like, I kind of wish I had gone with the foam version. But end of the day, it's a really good. But I'll keep thinking about if there's like a better answer. I'm pretty happy how it's
You said, like,
Yeah.
if you're gonna go 90% of the way with the windows, just throw that last.
Yeah.
Yeah, that's fair.
Did you do any energy retrofit on the existing building, or do you have plans to do it in the future?
I do have plans. It's really hard sell for my partner because there's like zero payback. We intentionally don't want to raise the rent. There's not enough affordable housing in Burlington, and so we're like intentionally keeping the rent really low. And it's people that have become our friends. And so like the idea of doing major improvements that we would have to finance and raise rent is a little bit of a turn off. But I do want to do kind of like I have dreams of being really wealthy and like doing a full wrap and putting in new windows on the existing car. There's just very little payback, and gas prices are really cheap and make it financially looking for us.
Well, you've explored the math of if you were to effectively lower the energy bills and then raise the rent.
I've done the details.
Difference, and it just doesn't.
I mean, even if I did, the math was simple. It was like, say I can cut that energy bill in half, or even 2/3. It's still like the amount, like say take that money that it saves and add it to their rent. So like effectively their rent stays the same. No way that it even comes close to that ratio. But I also want to do it in like the best way. Like I don't want to take off the siding and put in a little bit of insulation. Like you might as well go all the way if you're going to do it. And so I'm kind of waiting for the siding to fall off on its own and me forcing my hand and then being like, okay, well, I'm going to do it as best I can. But it's, I think it would be a passion project more than a financial project. But I have to say, adding that square footage to those apartments and like 1/3, no, not 1/3, but like a little less than say a quarter of that space is built to pass housing. And so like it's like kind of like one less wall that the apartment used to have. Like 1/4 of the walls is now really good. And so the performance of the front two units already improved a bit. There's also a really difficult threshold of being like, well, I can't just do the envelope and make it super airtight without putting a ventilation system in it, which is super expensive in an existing retrofit. Especially like 3 bedrooms, the distribution for that is nuts. If there's a studio or an open concept, it's a lot easier. But with these small units that have like 10 by 10 bedrooms, getting the ventilation there is really challenging. So there's kind of like a barrier to entry to like if you start doing the envelope work, you also have to do the mechanical work, and you might as well put heat pumps in there. And so it's like a thread that you pull and you go up the deep. But one day.
Well, I mean, I think you make a good point about the strategy of waiting until you need to make these repairs anyway, and then making improvements rather than just maintaining.
Yeah, there's like sustainability wise, like there's something to like letting something go to the end of its life, usable life. Mechanical equipment and siding and all that has a carbon footprint that we already paid for it. So.
Well, I will say, I saw like one of the after pictures in one of your early slides, and then you skipped to the before picture, and my first thought was like, you tore down that perfectly good house and built that new slick looking one. I was like, oh, that doesn't seem like the best view. So when I saw that you added that on to the back and retained the function of the existing building, and did it in a way that actually, like, you didn't kind of do the aesthetics a whole lot, like, so it looks like some of those lines from the decks and stuff kind of,
Full cross.
like, it's definitely new and different, but it's not an alien. And I appreciate that.
There was some contention with historic in that it's taller. But I think it was technically historically eligible, but not historic per se. Not on the register.
Can you flip back to one of those slides from the sidewalk? There's definitely a dialogue between the old gable facing the street in the front and the new gable in the back.
Yeah, it's interesting. The gable versus flat roof is one of those early questions when you're designing a building you like obsess over. And love the look of a lot of flat roof buildings. There's absolutely no way to do it without foam. And so I have all these little like lessons that are technical. I'm like, okay, I'm going to try not to do any foam buildings if I can. Like, unless it's like a really wide building, you just can't put a gable on it. But like all my residential buildings, at least I'm starting to design with a gable or enough slope to vent it and put cellulose in there. I think like if we're all thinking about those types of strategies, we start getting a look. Like, passive houses, high performance houses, they start to look similar, and that's an architectural movement that I think nobody really talks about.
Even there's a new pattern coming.
There's like a pattern. What? I see a pattern coming. Yeah, it's all the sail ships is for sale.
Arthur, I used to live across the street from you.
You look from there.
You know me from here. But I used to live in the apartment building right across the street.
Oh, really?
171?
Okay.
Yeah.
Yeah.
That's just,
Were you there when this was built?
no, but I recognized it in like the neighborhood and I was like, oh.
I live in the same, on the opposite side of the street as well, about 5 doors up.
Oh, really? I think, what was it? I was there like 2013, 14.
Cool. Do you know that the barrier building is being on the market? It'd be fun to run it.
It is.
Well, thank you. Any last questions?
You good?
Yeah, thank you.
Good.